In the introductory video, I talked about the XY table of solutions, as well as the X and Y intercepts. You can use those to graph an equation. So we'll do that for this equation, and then we'll talk about slope. So the XY table of solutions. We'll start with the x-intercept. The x-intercept occurs when y is 0. So we'll plug a 0 into our equation and see what x is. Solving for x. So we put -3/2 in our chart. Now we'll find the y-intercept when x is 0. So we'll put a 1 for y on the chart. We have two ordered pairs. I'll pick a third value. Notice if we pick an x value, the equation's already solved for y, so it's easy to find out what y is. So let's say x is a 3. I chose x as 3 because I know it'll cancel with this denominator very easily. So this is like a 3/1. I can cancel the 3's. I'm left with so y is equal to 3. So when x is 3, y is 3. Now we have three ordered pairs. I'll plot them and then graph the line. -3/2, 0, that's a -1.5. So over -1.5, but no up or down. 0, 1, no back and forth, just up 1. And 3, 3, that's over 3 and up 3. So again, by connecting these dots and extending the line in both directions, I've represented all the solutions that there are to our original equation. We can also talk about the slope of this line. Slope, or sometimes they'll use the letter m, is a way of comparing the rise of the line to the run of the line. So it's a way of describing, in effect, the steepness of the line. So we'll say m is equal to rise over run. So if you pick distinct points where I know exactly where I am, say right here, let's go up the line and right here. To get from here to here, I rise up 2. So the rise is 2. And I run 3. So the rise is 2, the run is 3. This pattern continues forever, up 2, over 3. I'll always land back on the line. This equation is in slope-intercept form. It's so named because the slope is right here, and the y-intercept is right here when x is 0. So if this x is 0, this becomes 0, and you have y equals positive 1. So when x is 0, no back and forth, y is 1. That way you get on the graph. Since I know the slope, I can go up 2 over 3 and put a dot. I have 2 points. I could graph this line and I would have all the solutions to our original equation. I'll just do the slope one more time. Up 2 over 3 and put another dot. So we now have 3 ordered pairs. I don't really have to identify them. So with the equation in slope-intercept form, without having to use an XY chart, I was able to graph all the solutions to the equation. And as you can see, this is the same line and it's the same equation, but we use the XY chart. So hopefully you'll agree that this is a much easier way to graph the solutions to an equation. If you feel like you know how to graph this without using an XY chart, just using the slope-intercept form, pause the video and see if you can graph this equation. You start with the y-intercept because you have to get on the graph. Knowing the slope tells you the angle of the line, but you don't know where the line is. If you know the y-intercept, you can actually get onto the graph. So when x is 0, y is negative 2. When x is 0, y is negative 2. Now the slope is rise 3 and run 5. So we go up 3 and we run 5 and put a dot. We could do it one more time. I just like having 3 ordered pairs because it's easier to make my line very accurate. So we graphed the equation, and conveniently it was already written in slope-intercept form. This is what your line should look like. And I just want to take a second to emphasize that this equation is written in slope, there's your slope, intercept, there's your y-intercept form. So it's a good name, slope-intercept form. You'll use this a lot. So again, we're to graph the equation. It's given to us in slope-intercept form. If you want to pause the video, see if you can graph this equation. To get on the graph, we need our intercept. So when x is 0, this becomes 0, and you have y is equal to 4. So when x is 0, y is 4. Put your dot. Now you're on the graph. The slope is sitting in front of the x. It's easier to read if it's a fraction, so you can turn it into a fraction if you like. Up 6 over 1. And put a dot. This is a positive slope, up 6 over 1. But if I had negative 6 over a negative 1, this would still work out to be positive because negative divided by negative is positive. And I mention that because if I want to stay on my graph, I can go down 6 and back 1 and put a dot. And I could repeat that going down 6 and back 1 again. If you tried graphing the equation, you can compare your line to this one. Again, we're to graph the equation, which is written in slope-intercept form. Even though the intercept is not written explicitly, as it was in the previous equation, we can still find out what it is. When x is 0, this becomes 0, and you have y equals 0. So when x is 0, no back and forth, y is 0. You put your dot right here at the origin. The slope is 4/7. That's up 4 over 7. Put a dot. You have two ordered pairs. You could draw the line, and that would represent all the solutions to our equation. Since I like to have a third point on the graph when I draw the line, and if I keep going this way, I'll be off the graph that I have showing, I'll do the same thing I did on the previous problem. 4/7 can also be written as -4 over -7. So I'll go down 4 and back 7. Put a dot. So here we have all the solutions to our equation. So slope-intercept form is usually represented as y is equal to mx plus b. Remember I said m often represents slope, and in this case b is used to represent the y-intercept when x is 0. This equation is in slope-intercept form. Even though it has -3, that's fine. This equation's in slope-intercept form. Even this equation is in slope-intercept form. That is, it's solved for y. You have x with a coefficient in front, which is your slope. Slope is 2/5. I don't have to write the y-intercept when x is 0, y is 0. It would be inefficient to have to write plus 0, so we don't bother to write it. But the main point is these three equations are in slope-intercept form. You're expected to have this form of the equation memorized, so when I have something that I need to keep track of, a lot of times I'll put a box around it just to help it stand out in my notes. Now you'll also be given equations in standard form. A, B, and C are basically constants. They're numbers that you're given. The x and the y are the variables. So this equation's in standard form, this equation's in standard form, and so is this one. For an equation to be in standard form, you cannot have fractions. If you have any fractions, you have to clear the equation of fractions. So you're expected to basically memorize the slope-intercept form of an equation, and you also should be familiar, that is, memorize, the standard form of an equation. So I'll put a box around this one as well. So oftentimes you'll be given an equation in standard form, told to write it in slope-intercept form, and then graph it. So we'll do that here. Basically, I need to get y by itself, so I'll get rid of the 2x. Get rid of the 6. This will reduce to a -1/3. And this will clean up to a 3. So here's our equation. It's in slope-intercept form. So I'll go ahead and graph it. When x is 0, y is 3. When x is 0, y is 3. My slope is at negative 1/3. So that means down 1 and over 3. I can repeat that pattern. We have an ordered pair right here. I put a dot. And then down 1 over 3. Put another dot. Down 1 over 3. I came down here just because I like having an intercept. It's a good, clear point. So this line has a positive slope. Going from left to right, it goes up. We can say exactly what the slope is if we can find 2 points that are very distinct. So right here I can tell exactly what that point is. It's a -3, -2. And going up the line, I can tell this point is a 1, 1. So if slope is rise over run, I rise 3 and I run 4. As you can see, that's a positive fraction. Now this line goes downhill from left to right. It has a negative slope. Remember, slope is rise over run. So we need 2 distinct points. This is a very clearly identifiable point. That's 4, -2. And this is clearly identifiable. So the slope of this line is down 2, 3, 4, and over 1, 2, 3, 4, 5. So it's down 4 and over 5. Now notice if I had started here and gone back 5, that is -5, I would have gone up 4. So I could also write this as 4 over -5. Both of these indicate it's a negative slope. Usually, we just put the negative in front of the fraction and know that this applies to the numerator or the denominator. The main point here is this is a negative slope. It goes downhill from left to right. Two other situations are when your slope is 0 or undefined. So let's explain this a little bit. Slope is rise over run. So does this line rise at all? No, I would say the rise is 0. Does it run? Well, yeah, it keeps going forever, so I'm just going to say the run is infinity. So I'm going to say 0 divided by anything is 0. So the slope is 0. One way to remember this is a horizontal line is that it matches the horizon. And to remember that a horizontal line has a slope of 0, it's helpful if you understand the logic. But notice that the word 0 sits against that very nicely. Now let's take a look at what happens when we say there's no slope. Again, slope is rise over run. Does this line rise at all? Well, yeah, it rises forever. I'll just say the rise is infinity. Does it run? Does it go back and forth any? No, the run is 0. In math, we cannot have 0 in the denominator, so this slope is undefined. It is a vertical line. A convenient way to remember that a vertical line is an undefined slope is the word undefined sits against it very nicely. So again, 0 slope is horizontal. Undefined slope is vertical. Sometimes they'll say there's no slope. If you're only given 2 points, you can find the slope using this formula. We could graph these 2 points and then graphically count and figure out the slope. We'll verify it using that method, but we'll use this formula to find the slope algebraically. Again, when I'm given a formula that I have to memorize or keep up with, I like to put a box around it. So we'll use these 2 points and this formula to figure out the slope. These are 2 ordered pairs. It's always xy, xy. But here they're using y sub 1, y sub 2, x sub 1, x sub 2. So I'm going to label these. X sub 1 and y sub 1, x sub 2 and y sub 2. That way I can keep them straight in my formula. So y2 minus y1, here's y2, it's a 3. y1 right here is a 1. They want x sub 2. X sub 2 is a 2. And then x sub 1. X sub 1 is a negative 4. So we'll clean this up a little bit. In the numerator, we have 2. I'll rewrite this with 1 sign. And this can be simplified. So our slope is 1/3. Let's go ahead and graph these 2 points and verify that this is the slope. So negative 4, 1. And 2, 3. We'll graph this line. So to verify, remember slope we use m oftentimes is rise over run. So if we start here, we had to rise 2 and run 6. We rise 2 and we run 6. 2 6 can be reduced to 1/3. Let's see what happens when I try a slope of 1/3. That means I go up 1 and over 3. I land right on the line. Up 1, over 3. So either way, I have the correct slope. We would expect it in simplified form. So in review, if you're given 2 points and asked to find the slope, you'll use the slope formula, and anytime you have a fraction, you simplify it. Now if you're given a point and a slope, you can graph the line. First graph the point, negative 4, 1. And knowing that the slope is 2/5, you go up 2 and over 5. You put your dot. You can repeat this. Up 2, over 5. The last 2 things that we have to talk about with slope are parallel lines and perpendicular lines. I'll go ahead and graph this equation and this equation, and then we'll talk about parallel lines. So first, to graph this equation, when x is 0, y is negative 4, and the slope is up 3 over 2. And now this equation, when x is 0, y is negative 1, and the slope is up 3 over 2. So we've graphed the two equations. I think you can plainly see the lines are parallel. Notice the slopes are the same. Now for the perpendicular lines, first I'll graph the lines and then we'll talk about the slopes. So for this line, when x is 0, y is a positive 2. The slope is 1/4, so that's up 1 over 4. And then for this equation, when x is 0, y is 3. Slope is down 4 over 1. So you can see that these lines are perpendicular, that is, they intersect at a 90-degree angle. And when you compare the slopes, this line has a slope of positive 1/4. This line has a slope of negative 4 over 1. The slopes are negative reciprocals. That tells you the lines are perpendicular. So a quick review, you can approach it either way. If the slopes are the same, the lines are parallel. If the lines are parallel, you know that the slopes are the same. If the slopes are negative reciprocals, the lines are perpendicular. If the lines are perpendicular, you know that the slopes are negative reciprocals. If you would like some practice with the concepts covered in the video, as long as you're at my website, I have this worksheet which is 7 pages, 29 problems. Oftentimes there's only 3 problems to a page because the graphs take up a lot of room. And as always, I have a detailed answer key.